Hi everyone, welcome to this second section of revision for the most important formulas about the gravitational field. Okay, here you've got 5 new formulas to revise. The first one is about the gravitational field, the gravitational potential, letter V. The formula is very similar to the other two that we already saw, gm1m2 over r squared, gm over r squared, and gm over r. These three formulas, they all have got pretty much the same structure. Let's not forget the minus symbol, okay, the negative symbol, and you need to remember which is which. So the first one is the force, the second one is the field, and the third one is the potential. Okay? Remember that the first two formulas, the first two quantities, they are vectors, while the gravitational potential is a scalar quantity. Okay, on top of that, in this slide, we've got another two sets of formulas. Two are for the energy. The first one at the top is the formula for the gravitational potential energy, and the one at the bottom is the formula for the mechanical energy. Okay? Remember that the mechanical energy is the sum of the kinetic plus the potential. Okay? And in the case of a gravitational force, it's important to remember that energy is conserved. The gravitational field is a conservative field. And then we've got other two formulas to remember, and they are the one for the velocity. You've got a formula for the escape velocity and the formula for the orbital speed. Please don't confuse them. Again, their aspects are very similar. We've got the square root in both of them. We've got the r that goes to the denominator, but the escape speeds come with a factor of 2, okay? And the r is not the same. R does not have the same it's not the same concept. One is the r of the object you want to escape from, so is the size of that object. So if you want, for example, a satellite to leave the Earth's orbit, then the r that you need to substitute here is the radius of the Earth. And the other one, or if we're talking, for example, about the black hole, now that these days we heard of the black holes in the news, we would be talking about the radius of the black hole. Instead, the r that you've got down here for the orbital speed is the distance from the satellite to the orbit, the satellite to the center of the body. Okay, so you've got your bigger object here at the Earth, and that's a satellite. The formula for the orbital speed, so if you want to determine how fast your satellite is traveling, then you need to measure, you need to substitute the value for this distance here. Okay? This is the r that comes here. Instead, if you want to work with the escape speed, the situation is the following. You would have a satellite here on the surface of the Earth. You want it to get enough velocity to run away and unbound from the Earth. Then you need to give a certain speed, and then the r that you get here is the radius of the Earth in this case. Okay, that's it in terms of formulas.